Okay, so we're going to run through home slices, my friends. Some of the summary statistics, and we're going to start with the measures of central tendency, which I am sure that somewhere in your educational career you have run across. Mean, median, and mode. So I'm not going to spend a lot of time on these because I'm figuring you probably have this down. But we will spend a little bit of time making sure you get it. And of course you can always rewind it or come up and ask me if you get stuck. So we have a set of data. This set of data, as it says on the paper that you got it from, are actually measurements of, if you recall, there was a nail embedded in the block of wood that we were working on, and it is the thickness of that nail, which theoretically should have been identical for everybody. But this is what statistics are all about. You can see here, not everybody got the same measurement. Some of it was because of, minor error in measuring. Others was that the nail itself isn't always made exactly the same. It's close, but not always exactly the same. So you can see there's some variation here, obviously. And what we're working on is getting a handle on how much variation, how close are the numbers to, figuring out a feel for what the numbers are like. Measures of central tendency are going to give us an idea of what the thickness of the nail is likely to be, or the number it's closest to generally. And then variation is going to tell you how widely our data here varies, how widespread it is. So mean. Mean is what you would know in the real world is just what they call the average. And that is, now you can write it all kinds of funky ways. In the notes you took, they use, I think, the sum. This means add up all of the sum, or add up a bunch of different values. And let's see here. Let me look and see. Not this one here. And maybe it's in here. There it is. So they describe the mean up here. In fact, here I'll clip it and put it in there. Like this. Now, I don't know, what the heck does that mean, right? Mean, no pun intended. But what they mean is add up all the values. So if you had to describe to someone how to do the mean, you would say add up all the values. Well, that's what this is talking about. It's saying, hey, add every single one of these numbers together. So this means the sum of, right here, all the different values in the set. And then divide it by the number of numbers. How many are there? How many values were there? Well, in our case, let's just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So n would be 16 in this case. The symbol they use is mu, a Greek letter. We've run across it before in a couple places. I never seem to be able to write it well, but it's a U or a pointy M, or it looks like that, there. So that's the mean. You'll also sometimes see X with a bar across it for average. That's also a symbol that's used. Sometimes I'll just write mean. Like in this case, I'll just write mean. So what is the mean going to be? Well, we're going to have to take the time to get a calculator out and add every single one of these numbers together. Now, I'm not going to sit here and have you watch me do that. I want you to take a second, find what that sum is, and on your paper, write it here. And then we're going to divide that by, we said, 16. So do that and see what the mean is. At this point, you should pause the video, take a minute or two, and do that on your own, because just watching it and writing down what I write will teach you nothing. So you have to realize this and be mature. Pause the video, practice it now, make sure you get the same thing I get, and if you don't, rewind the video, see if you figure out what you did wrong, or come up and see me, or just be a little more careful, because sometimes it's just a matter of making a mistake in there. So pause the video and see what you get for the mean. Alright, so welcome back. And what you would have done, or should have done by now, is, let me do this and this. Okay, so here's my little virtual calculator. Whoops, where'd it go? Hey, come back. There we go. And I got a sum of 2.0519 when I added up all of the numbers on the left here. And then, when I divided by 16, I got a mean of 0.1282. And when you find the average, you always want, or most of these statistics, you want to take the decimal place one place past the number that you were given. So, like, for example, all these numbers over here have 4 given to 4 decimal places. We're going to take our mean to one more decimal place past that. So when I look at my number on my calculator, it's 0.128243. The number after the 4 over here is at 3. That tells me to leave the 4 at a 4. So that's why, and not round it up to a 5. So that is why this is what I write. So my mean would be this value here. What about median? Well, what we're going to have to do with median is you're going to have to take a moment and write these numbers in order from smallest to largest. So we're going to redo this list from smallest to largest. And then we're going to talk about what the middle numbers are. So what you want to do is, I'll do the first few with you here. So the smallest number here, let's see, is there any 0.11s? I don't see any. So we're looking for, what I would suggest is ignore the point for a second and just worry about 1,321, for example. Just use it as thousands. So this way, if I was going to give you the money, which is the least amount of money up here right now, if you just consider those 4 digits. And I'm thinking 1,220 would be the least amount of money that I see up there. So that's going to be, I'll put that one first, 0.1220. When I do this, I like to then check off that I've got them, so I don't. And so forth and so on. And you might make a mistake and have to go back. Like the next one I'm seeing is 1,222. 0.1222. $1,222 if you want to look at it like that. Got that one done. Let's see, are there any more 1233? 1231. So I'm going to go with that. 0.1231, and then I saw a 0.1233. I might make a mistake as I go through here. Let's see. I see a 0.1250. Ooh, put anything less than that? 1245. So here we go. So I see a 0.1245. I see 2.1250s. Interesting. That's going to come up in a minute. And I got, after that, I think there's a 0.1261. A 0.1272. A 0.1279. And a 0.1298. And then I think I'm out of the 0.12s and I'm into the 0.13s. So let's see, I got a 0.1321, 79, 45, 79. So I'm going to go 0.1321, 0.1340, 0.1345, and then 0.1379 shows up twice as well. Interesting. And that should be everybody. So for the median, after we do that, we want to pick out the middle number. Well, we have 16 numbers here. that means the top half, 1, 2, 3, 4, 5, 6, 7, 8, and the bottom half are also 8 numbers, right? That means the middle here is actually between 8 and 9, because half of the data would be above and the 8, and these 8 would be below. When that happens, when you have an even number of numbers, you're going to just find the average of the two ones in the middle. So we're going to add up 0.1261 plus 0.1272 divide by 2. So if there's an even number of numbers, you will take those two middle ones and average them. If there are an odd number of numbers, there'll just be a single number sitting there, and you just take that number as the median. So in this case, I've got 0.1261 plus 0.1272 and then divide by 2 when I get that answer, and I got 0.12665, and we'll leave it at that. So that's going to be the median, my fault, is 0.126, I already forgot. That's how quickly I forget. 0.12665. Median is taken care of. Now, let's look at mode is the next one. And I'm going to point out here that we already can see a little bit about the mode here and here are interesting numbers because they're the only numbers that show up more than once, for example. What we look for in the mode is this. In fact, I'm going to take this. Whoops. Let's see if we can do this. Copy. Let's take it down here to the mode. The reason this is important is because the mode is all about what number appears the most often. Well, in this case, some cases, there may not be any number that appears more than once. So in that case, you would say there is no mode. Sometimes there may only be one number that appears the most. In this case, we actually have two numbers that appear the most often. And they are, fairly obviously, 0.1250 and 0.1379. So this set of data is actually what we call bimodal. It has two, bicycle, two wheels, it has two modes. And it is bimodal, and the two modes are 0.1250 and 0.1379. If there were three numbers that appeared more than anyone else, but the same amount as each other, then we would say it's multimodal. Let's move on to measures of variance. So this is how widespread the data is, we'll say. And there are two measures that we're going to discuss. And one is ridiculously easy, and one is a little more complicated, not going to lie. In this case, the range is the easy one. We'll start with the easy one. Range is simply your largest number, the largest value in your data, minus your smallest. So, for us, going back and thinking about when I had to put them in order, it would be the largest value, which is that 0.1379, minus the smallest value, which I believe is 0.1220. We can double check that if you like. 0.1220 is your smallest. I don't think, somehow it didn't get copied over here. So let's go back one more. There it is. So 0.1200 is your smallest, and 0.1379 is your largest. That means 0.1379 minus 0.1220 equals. Range is 0.0159. That was the easy one. Now, I want to pause the video, take a deep breath, because we're getting ready to attack standard deviation. And it's going to be a multi-step process. And, well, let's start with this thing right here. That looks ugly. What it is telling you to do is the following. It's saying, first, for every number in the set, take the number and subtract the mean, the average. So for every number, subtract the average from it. That could come out positive or negative, depending on whether the number is less than the average or more. Doesn't really matter. After you subtract it, and this is for every number now, we do that for every number, and then after we get that difference, we then square it. We do that for every single number. And then, whatever that value is for each number, we add them all together, and then divide by how many of numbers there are. In this case, that will still be 16. And then when we get that number, the last thing we do is take its square root. So to do the standard deviation, a table like this is going to help you tremendously. This is our numbers, and I've listed them here. You'll probably want to take a moment and write them down. This is, for every number, it is the number minus the average. And then whatever we get in this column, we're going to square it over here. So take a second, copy this table down into your, pause the video, and copy this table down into your engineering notebook. Don't be lazy. Don't, make sure you do this, because you're going to have to do this on your own not too long from now. And so, it's not going to do you any good to come to me, write down what I write down, and come to me later and be like, I don't know what I'm doing. Well, you have to practice it. You got to try it. You got to do it, not just watch me do it. So take a moment, copy this table down, pause the video, and when you come back, I'll be going through this step by step to show you what to do. So here's what we're going to do. First of all, what was the average? Because I need that. Up here you'll see I need to know what the average is in order to make this happen. So we go back and we remember, in this case I'm going to go back to that. The average was right here, 0.12824. 0.12824. So for every one of these numbers, what I'm going to do, I'll just do it for the first one here. What I'm going to put into this box is going to be the number, whatever it is, 0.1321 in this case, minus the average, 0.12824. So I do that on my calculator, 0.1321 minus 0.12824 equals. I'm going to write that number down in that box. So that's going to be 0.00386. And I'm going to do that for all the rest of them. So every single one of them, I'm going to take the number. So for this one, I'm not going to do them all with you here. I'm going to set you loose, and I'll give you you can compare what I get to what you get. 0.1220 minus 0.12824. Now notice, with this one, you're going to get a negative number. 0.122 minus 0.12824 equals negative point. Let me get rid of this line here because that's going to help me. Negative point. I forgot it already. I got this. 00624. And so forth and so on. Take a moment. Get that for every single one of them. Don't worry about this column yet. But pause the video, and when you come back, I will have all of these plugged in there. And you can see if you did them right. Okay, through the miracle of modern editing, there they are. Hopefully, you've paused the video and done this on your own. I cannot stress enough that if you did not, if you just waited for this moment, just let the video run and now copy these numbers down, later you will probably have no idea how to do this. And you will be asking me for help, and I will be telling you, did you watch the video? And if I don't help you, I hope you understand. So, and by the way, I used a spreadsheet to do this, and guess what we're going to learn next? We're going to learn how to use a spreadsheet to do these formulas, which will make your life momentarily harder because you got to figure out how to use a spreadsheet, and in the long run, though, it'll make it much, much easier. Next, what we're going to do is for each one of these numbers, we're going to simply square it on our calculator. So we're going to type in 0.0039, and we're going to square it. And in fact, let me do this real quick. I'm going to but we're going to go back to here, and I'm going to tell this thing, you know, I think I want another decimal place or two. There we go. I'm going to take it out to like, yeah, that many decimal places. So I'm actually going to cut this. Giving you a secret to how I do all this. There we go. Put it back in here, paste it. I'm going to get rid of this one. Put this one in its place. I'll take it out to a couple more places so it might look more like what you're doing. There we go. So I'm going to square this number right here. I'm going to get my calculator out, and I'm going to type in 0.00386, and I'm going to square it. And since it's a number less than 1, that answer will be even smaller when I'm done. See? It's going to be tricky putting this all in there, but we can do this. So it's going to be, how many zeros? 4 zeros. Yeah, it's definitely going to be tricky. 0.000014, boy, 8, but if I round, let's say I want to round this one, that's going to bump it up, so it's going to be really 1490, we'll say. 1490. Generally, you're going to try to avoid rounding for as long as you can. I have limited space, so if I was you, I might try to write out more decimal places. What you're going to do is the same thing. Again, you're going to square these numbers. Notice that when I take 0.00624, which is negative, there's a way to make this come out negative. Hold on, I got this. You're here somewhere. There it is. Boom. When I take that number, which is negative, and I square it, right here, notice it comes out positive. So all these are going to come out positive. 4 zeros, we'll call it 3894. So this is going to be 3894. If I remember correctly, let's just double check. Yes, when we round it, that's what it would be. And we're going to do that for all the rest of them here. We're going to square these values using our calculators. Take a moment, pause it, and take care of that. Make sure you know how to do it. Make sure you're getting them right. You'll be able to check it against what I have in a few moments after you pause it. Okay, so I've gone and done that. Once again, I use the spreadsheet sheet a little bit for time's sake, but I want you to realize that I'm here doing this at 10 o'clock at night. So while you're home playing video games, I'm still at work. So don't whine at me for using a spreadsheet. So your numbers may look a little differently because the spreadsheet is able to carry out like 10 or 20 decimal places. So because you probably rounded here and there, you'll notice that your numbers are a little bit different. Don't panic if they're a little bit different. That's not a big deal. Now, we're going to then take all of these numbers. So let's go back to our equation. We have now done the xi minus mu, this thing right here, for all, squared, that is, for all of the numbers. Now we have to add them up. That's what the sum means. So you're going to add up all of these numbers. And then, after you add them up, that will give you this. Then you'll have to divide by the number of numbers, which are still 16 in this case. And then we'll take the square root. So let's find that sum, shall we? Once again, I'm going to cheat a little bit. I'm going to add them up using the spreadsheet and giving you a little glimpse of the future here for you. So when I want to add up all those numbers, I'm going to put down here, I'm going to say equals sum. And I'm going to tell it to add up from there to there. And I'm going to hit close the parentheses, hit it, and look at that. All taken care of. So the sum is 0.00044333, we'll say. Now, I know you're doing it by hand, and I want you to appreciate that when I start saying, hey, we're going to learn how to do this on Excel, please don't sit there and whine at me and say, why do we have to learn how to do this? Because it's a pain otherwise. So we know the sum is that value. Now, what are we going to do with this sum right here? That is really right here. That's that number right there. So we are going to divide it by the number of numbers. We're going to divide it by 16. That's the next step. So I'm going to take my standard deviation. Oops. Sigma, I think. That's lowercase Greek letter sigma. Looks like a 9 that's fallen over. Is equal to square root. I got 0.00044333, many decimal places as I can take, divided by the number of numbers, which is 16. Get an answer there. I'll do this one the old-fashioned way. So I got 0.00044333 divided by 16 equals this. Standard deviation is going to be equal to the square root of that number. I'm going to use my square root key on my calculator, which looks like this little guy right here. I hit square root. Boom. There it is. Whoops, I lost it. 0.005, one decimal place more. We had 4 decimal places before. 1, 2, 3, 4. So let's go 0.00526. This 3 here lets me keep this as a 6. So 0.00526, we'll say. So the standard deviation comes out to be 0.00526. that's a number that gives us an idea of how spread apart the data is. Notice that's still out in 3 places here, right? 1, 2, 3. So the variation is about 5 in that decimal place. That's what that kind of tells us there. So that, my friends, is how to do standard deviation. Next step is, after you completed this, check with me, but you're probably going to get another set of data to do this all on your own from beginning to end, from mean all the way through standard deviation on your own. And then probably a quiz after that. Have a good one.